Good morning. In my course of teaching, I discovered that students find it difficult to balance chemical equations, and that is why I made this video to explain the basics of balancing of chemical equations. First of all, what is a chemical equation? A chemical equation is a symbolic representation of a chemical reaction. A shorthand way or a shorthand representation of a chemical reaction using symbols and formulas. For instance, the formation of water. Hydrogen combines with oxygen to form water molecule. The water you drink, that's H2O, that's the formula for water molecule. Hydrogen combines with oxygen to form water. This statement can be represented in this form. H2 plus O2 will give us water molecule. The arrow means yield in this context. So we find out that hydrogen molecule combined with oxygen to yield water molecule. The representation of this statement using these symbols and formula is what we call chemical equation. Then, why do we balance chemical equation? We balance chemical equation to obey the law of conservation of matter. What does this state? This law states that matter can neither be created nor destroyed in a chemical reaction, but changes from one form to another. Matter can neither be created nor destroyed during a chemical reaction. Let me explain using this. Let's assume you want to cook rice and beans, plain rice and beans, nothing added. Then you brought a cup of rice, and assuming in 1 cup of rice we have 20 tiny pieces of rice. Then you brought 1 cup of beans, and in this 1 cup of beans you have 10 tiny pieces of beans. You combine the two and cooked it plain, and let's overlook water. Maybe you cooked rice and the raw rice and beans. You will have a different form. You have cooked rice and beans in this pot. It is no longer the former one. It doesn't look like the former one because it is already cooked. And you cannot change this back to the raw rice and the raw beans. That is why it is a chemical change. It involves chemical reactions. And even though this has changed to cooked form, if you count the number of the tiny pieces of rice here, it will still be 20 pieces of tiny rice. And if you count the number of beans here, it will still be 10 pieces of rice. Nothing changed, unless some of them fell off while you were cooking. But if nothing happened, nothing fell off, you still have the same number of rice you had initially and the same number of tiny pieces of beans you had initially. So after cooking, nothing was created, nothing was destroyed. The only thing is that the beans and rice changed from raw form to cooked form. So the number of beans and the number of pieces of rice remains the same. That is what law of conservation of mass is saying. Matter is neither created nor destroyed during a chemical reaction, but changes from one form to another. So when you look at this, the formation of water molecule, initially we don't have water molecule. What we have is hydrogen and oxygen. Before the reaction, we had only hydrogen and oxygen. You know oxygen now, and you know hydrogen. Then, but after the reaction, we no longer have hydrogen and oxygen. What we have is a water molecule. Water, and not a different form of a chemical. So, but if you look at this, in water molecule, we still have hydrogen atoms and oxygen atoms, even though they are no longer in the initial form, in the reactant form. Then, if you look at the quantity of hydrogen in this side, we have two atoms of, we have four atoms of hydrogen here. That's 2 multiply this. 4 atoms of hydrogen. Here we have 4 atoms of hydrogen too. And here we have oxygen molecule, and in this oxygen molecule we have 2 atoms inside. And here we have 2 atoms. How? Because these two represent, these two covers both the hydrogen and oxygen. These two here, the two in the front, covers both the hydrogen and the oxygen. These two highlighted now covers both the hydrogen and the oxygen. So we have 2 oxygen atoms. So even though we no longer have separate hydrogen and separate oxygen, we have water molecule. But if you look at them, the same number of atoms in the right hand side is the same number of atoms in the left hand side. That is why we balance chemical equation. We have to make the number of atoms in the left hand side to be equal to the number of atoms in the right hand side. That is what law of conservation of mass is saying. Okay? Now, how do you know a chemical equation is balanced or not? How do you know whether a chemical equation is balanced or not? You know whether a chemical equation is balanced or not by doing what we call atom count. You count the number of atoms of each element at the reactant side. That is at the left hand side. Sorry, this mistake. That is at the left hand side, and count the number of the same atoms of the same element at the right hand side. The atoms of each element at the left hand side must be equal to the atoms of the same element at the right hand side, which is the product side. If you look at this, let's find out. This is the formation of water molecule. Let's see if this equation is balanced. In the formation of water molecule, remember we said we need hydrogen and oxygen. Hydrogen reacts with oxygen to form water. So this is hydrogen molecule reacting with oxygen molecule to form water molecule. Water molecule is oxygen bonded to 2 hydrogen atoms, right? So, but look at this. We have hydrogen, we have oxygen, quite alright. Then we have, this is water molecule. So this is the formation of water molecule. But is the equation balanced? Let's check. This is the left hand side here. At the left hand side, we have how many atoms of hydrogen? This hydrogen molecule, and in this hydrogen molecule we have 2 atoms of hydrogen. So in the right hand side, let's see if we have how many atoms we have. We have 2 atoms of hydrogen, so that one is okay. Then this is oxygen molecule at the left hand side. How many atoms is in this oxygen molecule? We have 2 atoms. Okay, atoms of oxygen. Then this is water molecule. How many atoms of oxygen is in water molecule? We only have 1 atom. So if you look at this, the number of atoms of oxygen in the left hand side is not the same, is not equal to the number of oxygen in the right hand side. Because of that, this equation is unbalanced, is not balanced. So let's look at this one, the formation of calcium oxide. This is a calcium atom. The black atoms are the calcium atoms. And this is oxygen molecule. Let's see if this equation is balanced. We have 2 atoms of calcium in the left hand side. This is the left hand side. Then at the right hand side of the arrow, let's see how many calcium atoms. 1, 2. So we have 2 atoms of calcium in the right hand side. Then this is oxygen molecule. In oxygen molecule, how many atoms? 1, 2. So we have 2 oxygen atoms in the left hand side. And in the right hand side, which is in the compound product form, we have 2 atoms of oxygen. So calcium, 2 atoms of calcium reacting with oxygen molecule gives us 2 molecules of calcium, 2 calcium oxides, 2 calcium oxide, that's 2 molecules of calcium oxide. If you look at this, we have 2 atoms here. Then we have oxygen molecule. In this oxygen molecule, we have 2 atoms of oxygen. Then this is calcium oxide. In this calcium oxide, we have how many calcium? 2 calcium. This 2 in front is for everything here. So 2 calcium, because 2 multiply calcium gives you 2 calcium. Then this is oxygen. 2 oxygen atoms, because this 2 is for everything including oxygen. So 2 multiply oxygen will give you 2 oxygen atoms. So we have 2 calciums at the right hand side, left hand side, and 2 calcium oxide, calcium at the right hand side. Sorry, we have 2 atoms of oxygen at the left hand side, and we have 2 atoms of oxygen at the right hand side. So this equation is balanced. So the equation down here is the formation of ammonia molecule. I would like you to pause this video and check, do atom count, and find out if this equation is balanced or not. Okay, the next thing we are going to talk about is how do you balance a chemical equation. First of all, the first thing you have to know how to do if you must balance a chemical equation is to find out if the equation is balanced or not. Then the second thing is, if it is unbalanced, then you add appropriate numbers in front of the symbols and formulas to multiply them out. If the equation is not balanced, what you need to do is just to add appropriate numbers in front of the symbols and formulae to multiply them out. Example, balance the equation of reaction of chlorine with hydrogen. When hydrogen gas reacts with chlorine gas, it gives you hydrogen chloride gas. So look at this. This is the equation of reaction. Let's find out, is it balanced? In the reactant side, which is left hand side, we have hydrogen and chlorine. And we have how many hydrogen atoms? We have 2 hydrogen atoms. And how many chlorine atoms? We have 2 chlorine atoms at the left hand side. Then coming to the right hand side, we have hydrogen and chlorine too. So how many hydrogen atoms? 1 hydrogen atom. How many chlorine atoms? 1 chlorine atom. So this equation is not balanced. So we need to balance them. How do we do it? Our problem lies in hydrogen chloride, right? Because we have only 1. We are meant to have 2 to balance with this. So what do we do? What if we add 2 here? 2 in front of this. If you add 2, you will have something like this. Let's check if the equation is balanced now. So this is hydrogen and chlorine in the left hand side. How many atoms of hydrogen here? We have 2 atoms of hydrogen in the left hand side. How many atoms of chlorine? We have 2 atoms of chlorine in the left hand side. Now coming to the right hand side, how many atoms of hydrogen? We know that this 2 is for everything here, the HCl here, it will multiply 2. So we have 2 atoms of hydrogen. How many chlorine do we have? We have 2 atoms of chlorine. Therefore, this equation is balanced. Note, in balancing of chemical equation, you don't change the formula of the compound. The formula of hydrogen is H subscript 2. You don't say, okay, because I want to balance this equation, let me remove these 2. No, if you remove these 2, you have changed the formula of the compound. You don't change the formula of any compound, any of this stage. You only add numbers, coefficients in front. You are only permitted to add numbers to balance the equation. And I also want you to note that this is done by trial and error method. If you add 2 here and you check and it doesn't balance, you have to add another number you think will be suitable. It is done by trial and error method. Good. I believe you understand. If you have any question, you ask me. In the next video, I'm going to solve more practice problems so that we can get a strong foundation in balancing of chemical equation. Thank you for listening.